Hello students, this is Latif sir. Today I'll discuss about ICC class 9 chemistry. The topic is periodic table. Today I'll discuss about modern periodic table on the basis of atomic number. In the previous video I have told that Mendeleev was the first scientist who gave a almost successful periodic table, and he arranged all the known elements at that time in a tabular form, and he gave a periodic law. And the periodic, according to Mendeleev, the periodic law was physical and chemical properties of elements are periodic function of their atomic masses. Later, Henry Moseley was a, was a, an English physicist, Henry Moseley, who corrected the Mendeleev periodic law, and he gave the modern periodic law. And the modern periodic law is physical and chemical properties of element are periodic function of their atomic number. So what is an atomic number? Atomic number is the number of protons present in the nucleus. That is number of positive charge present in the nucleus of an atom. And Henry Moseley was the first scientist who determined the number of positive charge in the nucleus. Actually, during analyzing different X-rays produced from different metals, Henry Moseley found that the frequency of X-rays produced from different metals depends uh, on the atomic number of the metals of the different metals. Uh, That is, Henry Moseley conclude that the number of positive charge present in the nucleus of an atom is the most fundamental property of an atom. Hmm. Thus, Henry Moseley found the atomic number is a better fundamental property of elements compared to atomic mass. This led to the modern periodic law. And the modern periodic table. It looks like this. Okay, this is modern periodic table. Hmm. So, or long form of periodic table. Now, first explanation of for anomalies in Mendeleev classification of elements. I've told that there are very many demerits of Mendeleev periodic table and periodic law. Later, this demerits was solved by different scientists and IUPAC. And Henry Moseley corrected the Mendeleev periodic law and gave the modern periodic law. Okay. So, exploration for anomalies in Mendeleev classification of elements. First, position of isotopes. Since all isotopes of an element have same atomic number, they can be put in the same group. Okay, as they have same number of protons in the nucleus, the isotope can be put in same group. Second, position of argon and potassium. Atomic number of argon is 18, and atomic number of potassium is 19. As the modern periodic table, in the modern periodic table, the elements are arranged in increasing order of their atomic number. So, argon with its lower atomic number should come first, and potassium with its higher atomic number should come later. Okay. Now, periodicity in the modern periodic table. When elements are arranged according to increasing atomic number, those having an equal number of valence electron occur at regular interval or periods. And since the number of valence electron of element show periodicity, that is regular repetition, chemical properties show corresponding periodicity. Let us explain this by considering the following. Uh, Consider the alkali metals, that is group 1 elements of the modern periodic table. Uh, and the elements are lithium, sodium, potassium, rubidium, cesium, francium, and francium respectively. And their electronic configuration also given here. The elements: lithium atomic number is 3, sodium atomic number is 11, potassium atomic number is 19, rubidium atomic number is 37, cesium atomic number is 55, and francium atomic number is 87. Okay, their atomic number is given. From the atomic number, electronic configuration is also given here. From the electronic configuration, it is clear that all these elements have same number of valence shell electron, that is valence shell electron is 1 in all cases. So all these elements have one electron in each in their outermost shell, and so they have similar properties. And the similar properties are they are good reducing agent, they are form unipositive ion, they are soft metal, they are very reactive, and thus they are found mainly in combined state. They impart color to the flame when they burn. They form hydride with hydrogen. They form basic oxide with oxygen, and they react with water to form metal hydroxide and hydrogen. It is noticed that elements with similar electronic configuration have similar properties. Thus, the cause of periodicity is recurrence of similar electronic configuration. That is, if two or more elements have similar electronic configuration, they will their chemical properties will be similar. Okay, so the cause of periodicity is recurrence of similar electronic configuration. Now, salient feature of Mendeleev modern periodic table. In modern periodic table, there are first some groups and periods. Groups are vertical columns and periods are horizontal rows. In the modern periodic table, there are total 18 groups. Initially, the groups are represented by the Roman number 1a, 2a, 3a. Now it is the new convention of representation of group is 1, 2, 3. You have to number the group 1, 2, 3 as 1, 2, 3, 4, 4, 5, 6, 7, 8. There are total 18 groups. Okay, you can represent the group by using Roman number or English number. Okay, the new convention is you have to use the English number 1, 2, 3, 4, 5, 6 as this. So elements of subgroup A, that is of 1A, 2A, 3A, 4A, 5A, 6A and 7A, that is group number 1, 2, 13, 14, 15, 16, 17 are known as main group element or representative elements or normal element. This element have their outermost shell incomplete. And the elements of group number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 are known as transition element. They have their two outermost shell incomplete. The element in the zero group, that is group 18, group 18 are called noble gas, because owing to their stable electronic configuration, and the stable electronic configuration is 8 electrons, generally 8 electrons in the valence shell of the element. Okay, so as there is noble gases have mm, stable electronic configuration, they are non-reactive element. Okay, now periods. I have told that there are total 7 periods in the modern periodic table. Periods are horizontal rows. And they are numbered as 1, 2, 3, 4, 5, 6, 7. And total in the modern periodic table, total 18 groups and 7 period. The element with electrons increasing arithmetically in their outermost shell, that is one by one till its octet is attained, are placed in the same period. And the last element of each period has 8 electrons, except the first period helium has 2 electrons. Okay. Second point, the first period contains only two elements. Group atomic number is 1 and 2. That is hydrogen and helium. The first period contains two elements, hydrogen and helium. It is the shortest period. Second period and third period contains 8 elements. Uh, these are short periods, and the fourth and fifth period contains 18 elements. Hmm. The third and fourth periods contains 18 elements, and these are long periods. The sixth period contains 32 elements. This it is the longest period. And the seventh period, uh, the second period, which is incomplete period. You have to remember the which period of the modern periodic table is incomplete till now. The answer is seventh period. Okay. In group 3b or group number 3 of the sixth period, there is a set of elements with atomic number 57 to 71, that is lanthanum to lutetium, beginning with lanthanum La. Lanthanum formula, symbol of lanthanum is La. Atomic number is 57. Hmm. These elements are known as lanthanide or rare earth element. And in group 3b, that is group number 3 of the seventh period, there is a set of elements with atomic number 89 to 103, that is thorium to lawrencium, beginning with actinium. Actinium represent a symbol of actinium is 8 AC. Symbol of actinium is AC and atomic number is 89. So the group 3 and 7th period, there is a set of elements with atomic number 89 to 103, and these elements are known as actinide. All actinide elements are radioactive elements. And lanthanide and actinide elements have similar properties because they belong to the same group, group 3b. But they are shown at the bottom of the periodic table because they are large, and they are large in number, and showing them in the main body of the periodic table will distort its shape. And lanthanide and actinide elements are present at the bottom of the periodic table. You can see here lanthanide and actinide elements. Okay, thank you.